Okay, so let's discuss a question from design of brakes. You have a differential band brake which you need to, by means of a lever mechanism, you need to stop it. Okay, so we need to find out the maximum torque that the brake may sustain for counterclockwise rotation of the drum. Okay, so in this kind of problem, what we do is we try to draw the free body diagram um, of the drum, because from that only you will get to know which side is maximum tension and which side is minimum tension. Okay, so this is rotating in a clockwise direction. You have a torque acting in this direction. So this, the friction between the rope and the drum will be in this direction, friction. And if you take the rope separately, friction on the drum is clockwise, but the friction exerted, the force, basically the force exerted by the drum on the rope will be in this direction, F, right? So obviously this F plus this T should be equal to the right hand T. So the right hand T should be the max, right? Okay, so this is how you decide. There are two, I mean, there are many ways of deciding it, but the best way is when you know the rotation is anti-clockwise, so the friction exerted, you're drawing the free bar diagram of the drum, so the friction exerted has to be on the clockwise direction in order to balance it. So friction exerted, because the relative motion is towards left, the friction exerted by the rope is towards right. The same friction on the rope, when you draw the free body diagram, the right side is on the rope. So on the rope, the force, it's a Newton's third law, so every action has a equal and opposite reaction. The force exerted by the drum on the rope will be towards left, and so left force everywhere plus the left side tension will be equal to the right hand side tension. So the right hand side tension is max. The other way of saying it is, and in fact the easy way of saying it is, as it is rotating anti-clockwise and you want to stop it, so the right hand side tension has to be more than the left hand side tension, because effectively the right hand tension is providing a clockwise braking torque to the left side rotation, to the counterclockwise rotation. So that is the idea. So once you decide T max and T mean side, then what you can do is, for the drum, and the pulley, once you decide T max, so what you can write is T max by T mean is e power mu theta. Okay, so this is something which relates T max and T mean. So the first thing in these kind of problems is to find out which is T max and T mean. We have found out that. The next thing is relating T max and T mean. Now friction of coefficient is given as 0.4 and the angle of flap is 80 degrees. We have to put in radians. So 0.4 into pi. So 0.4 into pi is the thing. So from this we get 3.52 e power 0.4 pi. So T max, in fact this we can write as first equation, T max by T mean is 3.52. Now there are two unknowns, T max, both are unknown. Then how do I get this? So then we come to the lever. From the lever also we can relate. So if you go back to the lever, it is hinged in one of the ways. Okay, so this is my lever. So T max is applied in this way. T mean, it's always, tension is always away. Okay, so T max on the, see, on the pulley, on the rope is also away, on the lever is also away, and T max and T mean 220 is applied downwards, 220, and this is a hinge, so you will have some AX and AY. Okay, but what we will do is, because we are not interested on the hinge force, so about this A, if the lever is in equilibrium, which it will be, the moment will be balanced about A. So what we do is, and this distance is given, this is 100, T max is 100, the T max force vector is 100 mm and T mean 50 mm and 50 mm, and this A is basically at 200, because we are applying moment, so these values have to be there. Okay, so what we do is sigma moment about A has to be 0, so 220, so clockwise moments I take positive, It is, I mean, this is just sign convention to apply. I mean, you can take anti-clockwise movement positive, and then also you will get the same equation multiplied with minus throughout. So that essentially the same equation. So 220 into 200 is a clockwise movement. T max produces anti-clockwise movement. So T max into 100. T min about A produces clockwise. So plus T min into 50. So this is another equation which relates, and from this equation what we get is yeah, I mean, if you divide, so 220 into 2, if you divide by 50, okay, into 4 plus T mean is 2 times T max, right? So this is another equation. Okay, so we have two equations for T max and T mean, and if you solve, then what we get is T max is 514 newtons and T mean from these two equations. You can solve because two equations, two unknowns, you should be able to solve. 146 newtons. So you got T max and T mean. So once you get T max, what is asked is the torque. So now this T max and T mean about the center will produce what is the braking torque. So for this, what you do is you take a pulley as well as the rope as your free body diagram along with the pulley and the rope. So T max is this, T mean is this, and so the braking torque provided about the center of the drum is T max is T. So the braking torque that is provided is T max into radius minus T min into radius, right? Because T max tries to stop, T min tries to negate. So T max into R, the moment of both the tensions about the center is T max into R is clockwise, T min into R is anti-clockwise. So the braking torque has to be clockwise, right? Because it is moving to in the counterclockwise direction, the braking torque has to be clockwise. So T max into R is clockwise minus T min into R. So T max minus T min into R. So T max we already got, T min we already got. So 514 minus 146. R is basically diameter by 2 and diameter is given as 150 mm. So 150 mm by 2. So this will give you Newton mm, and Newton mm you have to divide by 1000 to convert into meter, right? Because the dia is in mm. So you get 27.6 Newton meter for this problem. Remember, it's Newton meter 20, and because it's asked in Newton meter, so 27.6 once you solve, that is the answer for this. So remember three things in this design of brakes problem. First is to decide which side is maximum tension, minimum tension. That you can decide based on the rotation of the drum. Get the rotation of the drum, and then the opposite direction. Like in this case, the drum is rotating in an anti-clockwise direction, so the T max has to be higher so that it can provide a clockwise braking torque. Once you get which side is max and min, then from the T max by T mean overlap equation, you get e power mu theta. The ratio is always related to e power mu theta, that is one equation, and the second equation will be from the equilibrium of the lever. Okay, so two equations for two unknowns, T max and T mean, and get individual T max and T mean, and then most of the time a braking maximum torque, that the braking torque will be asked, or basically how much power this drum can take. So the idea is to get T max and T mean, and then that is the minimum thing which you need to get, and then solve the problem depending on the question. Thank you.